Hello, everyone. Welcome to the January 20th, 2022 edition of our Big Data and AI Toronto 2021 follow-up series. We do have some excellent presentations for you today, so thank you again for joining us. Our first presentation is Lubos Parobek, who is the VP of Products for Pachyderm. And then following Pachyderm's presentation, we will be having a presentation from Ashkar Gorbani, who is the lead solutions engineer at H2O AI. We're going to get started with the first presentation.
Hello, everyone. I'm Lubos Parobek, VP of Product and Go-to-Market here at Pachyderm. Today, we're going to be talking about data ops and how to master it for machine learning. Today's agenda is going to cover three topics. First, we're going to discuss the journey most teams take as they move from exploratory efforts in machine learning to being able to regularly and reliably deliver new machine learning applications to their customers. Next, we're going to dive into how data ops fits into this machine learning journey and the specific challenges and opportunities of data ops in this context. Lastly, I'll provide a brief overview of Pachyderm and how our data versioning, pipelines, and lineage helps teams tackle these opportunities and challenges and accelerates their MLOps maturity journey. Almost every organization goes through a common maturity journey as they move from exploratory analysis, in other words, trying to figure out how machine learning can help their business, to getting that first model into production, and then finally expanding that success to multiple teams, use cases, and lines of business within their organization. Now, this initial phase is typically it's manual, it's slow, it can be error prone, and it typically involves a small team that's scrambling together data from a bunch of different sources, doing some development locally in notebooks, and they're probably using little or no automation. And the goal of this exploratory phase is simply to establish an initial proof of concept and help separate what's real from what's the hype in machine learning. And while a lot of early ML teams really focus on this phase, it's really after this step where the real challenges begin. Actually, getting exploratory work into production efficiently and reliably and proving that you can generate real business value entails a whole different set of challenges. You need to build out and utilize a complex set of MLOps tools to automate and productionize the ML learning lifecycle, and we'll talk about that more in a moment. But doing so begins to speed up the deployment of ML models, lets you iterate more quickly. It lets you start to scale out across many different models and allows for better team collaboration. Finally, after one or two teams have successfully productionized the ML development workflow for their use cases and are generating real value, other lines of business will want to also leverage machine learning. Now, without some centralized guidance and tooling, every different team might try to adopt a different approach and different tools. So to avoid reinventing the wheel every time, you'll want to standardize and scale your MLOps tool chain and process across all teams in your organization. And the purpose of this is you're going to want to make it easy for teams to train, deploy, retrain, and redeploy models frequently and with confidence. And you're going to want to make sure that teams can collaborate, share, and build on each other's work to deliver results autonomously, but in a coordinated fashion. You want them to be able to leverage each other's work. And throughout these iterations and this journey, you're going to see that everything boils down to two key components. And this will really be a focus of this presentation: managing your ML code, as well as managing your data. So as I mentioned, the machine learning lifecycle is a key thing here that we're trying to mature. And it's really the workflow for how you get machine learning applications from an idea to production. And it centers around, again, this idea of managing both data and code. And there can be some variance depending on the use case, but it typically boils down to these same four major steps for most organizations. The first is the preparation of data, so it's ready for experiments and training. The second is actually doing experiments and exploration to determine if your data sets and your algorithms are correct for the successful models you're trying to create. Third is training and evaluation of those models to see if they're successful for their desired applications. And lastly, it's the deployment of those models to production and then monitoring them. Importantly, these aren't linear steps that are executed one by one. They are incredibly iterative and are more like a living, breathing system that needs to be deployed and built out over time. Automating and scaling these processes are how teams mature their machine learning practices. So again, the first step in this process is data preparation. And this data preparation step is a major focus of data ops as it relates to machine learning, and can encompass activities such as data collection, often from a variety of sources, the transformation of that data, labeling of data, and finally, validation to ensure that data meets expectations and is in fact ready to be used in the rest of the machine learning lifecycle. But it's important to note that data management activities, for example, versioning, tracking, and processing data, continue throughout the machine learning lifecycle in the experiment, train, and deploy steps. In fact, data ops has a large role to play here in terms of tracking intermediate results, data sets, metadata, and evaluation metrics to ensure the end-to-end reproducibility of results. This reproducibility helps immensely when data debugging, as well as for audit and compliance requirements. Let's look at some of the unique challenges that data ops can face when supporting machine learning specifically. First, machine learning typically requires very large data sets that can often come from a variety of disparate sources. These data sets also tend to change frequently due to new or changed data. One example is using natural language processing for sentiment analysis. Large amounts of data might be coming in constantly from support emails and surveys, social media, and even voice transcripts. Scaling and automating to handle this large amount of disparate data can be challenging. Secondly, often multiple teams will be looking to leverage the same data set for different ML applications. For example, one team might be looking to do sentiment analysis on support communications, while another team might be looking to use the same data set for a chatbot. To make things even more complex, often multiple teams, multiple engineers and data scientists on the same team may want to access these same data sets independently to explore new ideas and optimizations through experiments. Lastly, some of the most exciting and valuable ML applications like natural language processing, as an example, use unstructured data. And unstructured data is basically data that does not fit nicely into database tables, but typically lives in files. Examples of this type of data include text documents, images, audio, and video. Some of the more common challenges of unstructured data include being able to process a large variety of file types, file sizes, and large volumes of files efficiently. Lastly, supervised learning is one of the most popular approaches to ML, and it very much depends on unstructured data and requires the labeling of data. And this labeling of data can be very manual, expensive, and time-consuming. Of course, data ops teams don't have unlimited budgets or time to deal with these challenges. They need to handle these new challenges in a cost-effective and timely manner that meets the needs of the data science teams they're supporting. To keep costs under control, they need to apply new automation and scaling strategies. For example, being able to horizontally scale out processing while avoiding any reprocessing of data when not necessary. Data ops teams also need to make sure that facilitating collaboration is a high priority. They need to enable a variety of teams and individuals on those teams to be able to share data sets effectively. This typically entails a robust data versioning strategy that allows these data sets, these shared data sets, to be shared out via concepts such as branching that enable a single source of truth to be maintained. A successful data ops approach and strategy will unlock several opportunities to accelerate machine learning in your organization. They include allowing data science teams to iterate faster on data. Preparing data can be very time consuming, and that can quickly become a bottleneck for the rest of the ML lifecycle. Making sure that data science teams have the data they need when they need it for experiments and training is a key opportunity to increase the effectiveness and maturity of your machine learning lifecycle. Another opportunity relates to reducing the manual effort and errors associated with manually triggering data flows or manually tracking data changes. Automating these tasks is a key opportunity to save time and improve reliability. A successful DevOps approach can also ease data debugging and data governance by providing a reliable and comprehensive version control system for your data sets. This is key to not only improving productivity, but meeting regulatory requirements. Lastly, as we discussed, some of the most innovative ML use cases are being built upon unstructured data like images, video, and text documents. Let's take a look at a few examples. NLP, for example, includes things like sentiment analysis, voice-to-text transcriptions, or analysis of financial or legal documents. Computer vision examples include medical diagnosis of X-rays or CAT scans, and facial and voice recognition for authentication. Examples of geospatial analysis include analysis of satellite imagery for crop yield forecasting or recognizing logistics bottlenecks. A data ops approach that makes unstructured data a first-class citizen will allow your data science teams to more easily pursue these high-value use cases. This includes making sure that your data ops approach can handle ingress and processing of very large numbers of files, as well as being able to handle individual files that are very large in size. For example, it's not unusual for high-resolution satellite images to be hundreds of gigabytes in size. Lastly, your data ops approach should be able to handle any file type. Okay, let's switch gears now and look at what a typical data ops pipeline looks like. Most commonly, it will be composed of three parts: ingest, transformation, and validation. Ingest is the first step and enables raw data to be brought into the system from multiple sources like databases, CSV files, and object storage, and then combined. Ingest typically supports both batch processing and streaming. To prepare ingested data for experimentation and learning, it needs to go through varying degrees of transformation. Examples of this type of transformation include standardizing file names, converting image files to a standard format, or removing extraneous columns from a CSV file. The last step in data validation, which seeks to ensure quality, usefulness, and accuracy of the data. Validation increases confidence that the data being consumed is clean and ready for use by ensuring it meets minimum expectations. Examples of validation include detecting missing data or highlighting outliers. Now let's look at some of the key requirements for data ops pipelines to support machine learning in particular. In terms of ingestion, we've already mentioned the need to be able to combine several data sources, as well as the ability to support both batch processing and streaming. In addition, ingestion should support unstructured data sources like object storage, as well as any file type. For example, image, video, and audio files. Ingestion should also be able to efficiently handle very large volumes of data that are changing frequently. For example, Internet of Things sensor data or satellite imagery. In terms of transformation and validation, it's important to be able to scale processing quickly and efficiently. Through approaches like horizontal scaling and parallel processing, it's possible to take an ML job that would take days to process sequentially and reduce it to hours. This ability to quickly and efficiently process large data sets is key to enabling quick iterations by ML teams for experimentation and training. You don't want data preparation to be a bottleneck in the ML lifecycle. It's important to also build in flexibility in terms of the languages and tools your pipelines will support for transformation. Different teams will want to use a variety of ML tools, and it's important to enable these teams to have the freedom to use the best tool for their particular ML task. Collaboration is also an important aspect to consider. You'll want DevOps pipelines that make it easy for teams to work autonomously against common data sets, but without disturbing each other's work, and also without unnecessarily duplicating storage or processing of these shared data sets. Lastly, because data plays such an important role in the effectiveness of machine learning models, you'll want an effective way to debug data issues. For example, if a new training data set results in a model that's performing poorly, you'll want to be able to quickly understand the root cause from a data perspective. Also, if you're in a regulated industry like life sciences or financial services, you'll want to make sure that your data pipelines support your required data governance and audit obligations. Now let's take a look at how Pachyderm can help you build data ops pipelines that will help accelerate your machine learning journey. Pachyderm provides two key capabilities to help you build your data ops stack. These are data-driven pipelines and automated data versioning and lineage. Let's take a look at how our pipelines working in concert with our versioning can help meet many of the requirements we just discussed. Pachyderm pipelines allow you to automate your data prep tasks into flexible pipelines. These pipelines are completely code and framework agnostic, so you can use the best tools for your particular ML applications. Our capabilities are also highly scalable and are particularly optimized for large amounts of unstructured data. Everything in Pachyderm is just files. So we work with any type of data, images, audio, CSV, JSON data, you name it. And we can automatically parallelize your code to scale to billions of files. Also, because Pachyderm understands versions and diffs of your data through our versioning, we can offer some incredibly unique capabilities such as incremental processing, where we only process diffs or changes to your data and can reduce processing time by an order of magnitude or more. Lastly, it's important to note we keep track of all changes to your data through versioning, including metadata, artifacts, and metrics. So you have end-to-end reproducibility, which provides immutable data lineage. This significantly reduces the effort to debug issues and helps satisfy many data governance and audit requirements. Pachyderm Enterprise is our commercial product offering. Pachyderm is container native, and we run on any Kubernetes flavor in any of the cloud-managed Kubernetes services or even on-prem. This lets Pachyderm leverage the cloud provider's core compute, storage, and networking resources. And because we're cloud and infrastructure agnostic, you have the flexibility and can easily switch between clouds or have a hybrid or private cloud system. This gives you full portability of your entire data ops system. And all of these infrastructure concerns are abstracted away from your core ML and data scientists who, frankly, just want to focus on iterating on your data and code to get successful models out to production rapidly and reliably. Okay, well, let's dive into a bit more detail on Pachyderm's key features for versioning, pipelines, and lineage, and help illustrate how they satisfy many of the requirements around data ops for ML that we discussed. First, Pachyderm's unique data versioning capabilities ensure that you capture a complete auditable record of everything with minimal overhead. All data is versioned automatically in data repositories using a Git-like approach that supports concepts such as commits and branches. This enables that effective collaboration that we talked about on shared data sets. And multiple individuals on a team can experiment while not disturbing each other's work. It also makes it easy to identify and revert bad data changes in near real time. Secondly, Pachyderm supports petabytes of data while minimizing storage costs. We do this via a unique storage architecture that uses content-based deduplication to dramatically reduce storage requirements. Next, our file-based versioning provides first-class unstructured data support by being able to handle files of any type or size. Pachyderm also provides a complete audit trail for data across the entire ML lifecycle, not just data preparation, but into experimentation, training, and deployment. In other words, Pachyderm has this capability built in from A to Z. Lastly, our versions are stored as native objects, not metadata pointers. This means that our data objects this means that data objects that are committed are not just metadata references to where the data is, but actual versioned objects or files stored so that nothing is ever lost. Now let's take a look at our pipelines. Pachyderm pipelines transform ad hoc processes into integrated and reliable workflows. Pachyderm pipelines are responsible for reading data from a specified source or input repository, executing code against that data, and then writing the results to an output data repo. These Pachyderm pipelines, as I mentioned, are completely language and framework agnostic. And our Kubernetes native approach means that we can run any code that can be like literally any code that can be put in the container. This lets data scientists and ML engineers choose whatever library works best for each pipeline step and makes transformation and validation of raw data much easier. Secondly, Pachyderm can auto-scale data processing without any additional code being written. Pachyderm pipelines can be configured to automatically parallelize based on the data and file structure in the repos. And this significantly reduces increases processing speed without having to know sophisticated parallel programming approaches. Next, Pachyderm's pipelines are automated and fire whenever new data is detected, saving developer time and avoiding mistakes. Pachyderm's pipeline engine is literally watching for changes constantly in any of the input data repositories, and each time it detects new data being committed to those repositories, Pachyderm deploys a Docker container code to process that new piece of data. Lastly, because Pachyderm's pipelines are working hand in hand with our versioning, the pipelines are smart enough to know when new or changed data has been committed versus duplicate data. Pachyderm can be configured to only process that new or changed data, which will significantly improve processing time and save on processing costs. Working together, Pachyderm's data versioning and pipelines then enable you to have immutable data lineage. This means that with Pachyderm, you're able to track every version of your data and code that produced the result and maintain compliance and complete reproducibility. You'll also be able to manage relationships between historical data states and provide a complete account of every step in the journey of your data from preparation to deployment. Lastly, our global IDs make it easy for teams to track this lineage and be able to rewind a result all the way back to its raw input, including all analysis, parameters, code, and intermediate results. And it's important to emphasize that Pachyderm data lineage is immutable, enforced, and automatic. And this is key. Many solutions track lineage by just logging some metadata to a database oftentimes done in user code itself. But this requires everyone to use the system perfectly every time. And just like a chain of custody for evidence, even if you do it 95% of the time correctly, one break in the chain can completely ruin your reproducibility. Pachyderm's data lineage is fully enforced by the system for every step in the process. You literally can't run a Pachyderm process without lineage being recorded. And it's all tracked as a fundamental property of the data, completely behind the scenes without ML teams needing to do anything themselves or in addition to their regular work. So let's take a look at a few companies that have seen huge improvements in their machine learning operations by implementing Pachyderm. LogMeIn is a great example of a company that saw huge processing efficiencies through Pachyderm's scaling benefits. They decreased their processing time from 7 days to just 7 hours. Royal Bank of Canada is an excellent example of a highly regulated organization that is able to continue to innovate quickly while still meeting strict compliance requirements using Pachyderm's lineage features. And lastly, LivePerson is a good example of a tech company that's able to handle complex data processing and model training needs through Pachyderm's automation features. They've also reaped substantial benefits in terms of speeding up their team's agility by decreasing processing time from 10 to just 1 hour. And that's it for our presentation today. Thanks for your time. And I want to encourage you all to come visit us at pachyderm.com, where you can find more product information, case studies, and sign up for a free trial. Thanks again, everyone. Bye-bye.
Thank you, Lubos and Pachyderm, for the wonderful presentation. Our second presentation is going to start momentarily with Ashgar Gorbani from H2O AI. He is the Building AI Apps and Driving AI. His presentation is going to be on building AI apps and driving AI adoption. Again, Ashgar is the lead solution engineer at H2O AI. Ashgar, thank you again for joining us. And if you do have any questions for the presenter, you can put them into the Q&A chat, and we will read them out to the speaker once the presentation's finished. Ashgar, whenever you're ready.
Awesome. Thank you. Hello, everyone, and thanks for attending. My name is Ashgar Gorbani. I'm with H2O AI. And what we are covering today is how organizations can accelerate AI adoption, and why that is important. Because while many companies now increasing their interest in investing in AI solutions and eventually integrating them into their existing process and business process, there are still significant barriers, as we see, that at organizational level that prevents them from actually seeing the results of these AI initiatives. And we, as a global AI company, that at H2O we have worked with many organizations around the world, and from small to medium, large enterprises across all industries, and we have seen what has actually worked and what hasn't. And today I'd like to share some of the key findings and the important points that we need to consider if which are very critical to enterprise AI adoption. And so before we start about those aspects, let's just quickly basically set the scene and set the context, and understand when we are talking about AI application, what we actually mean. Across a variety of companies, they implement a variety of different use cases, which eventually what they want to achieve with that, increasing business efficiency, some sort of reducing cost, increasing profit, or customer satisfaction, or those sort of stuff. For example, in consumer product market, AI actually, what they use in terms of AI application is to individualize, marketing services or product offering, and tailor cut each of these, products and services to individual need. And that is basically, opposite of, those sort of traditional approach where, the customer was treating these, masses and segments, and the offering was, in each segment more or less the same. Or, the same goes for, other industries like, in healthcare, there are organizations that are trying to implement AI solution where, they intend to provide an individualized, again, healthcare experience rather than mass treatment that we already know that not very effective and efficient. In other industries like manufacturing, what we see is other type of use cases like predictive maintenance, again to optimize in some sort of business process like maintenance, optimizing maintenance, and increasing the uptime of these of their equipments. So eventually, what all of these is intending to achieve, the variety of these use cases that we see is moving from being reactive to proactive, right? So, and with that, what we want to achieve is that increasing the again optimize the KPIs that we measure our organizations in some sort. The thing is that some studies from market research institutes, what we see is that they are estimating that this efficiency increase is going to contribute as high as $15.7 trillion within the next decade. So that's a big number, and and that's translate to increase of GDP in some regions up to 26%. All right, so everything sounds good, right? So we have AI use cases, we're going to implement it, and the economy is going to boom. But then where's the catch? The point is, as soon as we face the reality that rosy outlook is kind of fades away, the points that these sort of reports we have seen a lot. Most probably are not the first. This webinar is going to be the first time to report things like 80% of the project fails. We have heard these sort of reports a lot, and that's not the point that I wanted to make. The point is that many of these reports that we see that 80% failed, 80% of AI initiatives fail, is actually, if you go back to 2015 and those dates, still the numbers more or less this, were the same. So actually, the drama here is not that that's a drama. 80% of the projects fail, but what I want to highlight here is the fact that it's been that that rate was as high as that what we see today for a long time, and we have not been able to improve that. So, and that's something that we need to change. And actually, in order to do that, let's first look what really are barriers that prevent us to succeed with AI initiatives. So what we have seen, and also from many studies that has been done, there are some of these, at least comes in top of the list when we look at the barriers for AI adoption. And typically on the top is lack of clear AI strategy. So that's a problem that needs to be solved at a C-level. But what we need to, what I at least today I'd like to cover things that at least we can address with technology. And in that, if we look at the second item, which is functional silos in organizations, that many organizations pointed out as one of the biggest barrier in adoption, which we have already seen that when we're working with these organizations, they're not if they're different departments, different business lines, they're not aligned together, they're not working together. It's really difficult to get progress in AI initiatives. So in order to make sure that we are progressing that side, we need to make sure that any technology that we adopt, fosters collaboration within different within different units within all organization. And another point that we see often, in that, listed as part of the barriers is cultural resistance. And that's clear, we don't like to change, changes associated with uncertainties, and no one likes uncertainties. So in order to handle that, what we have seen that works very well, when we make things simpler, easier to understand. And when when I say that, reduce complexity, I'm not saying that, let's create a technology that has a one button, we click it and we get a solution. What I mean here is that we need to make it easier for everyone to understand that. So by making AI solutions more transparent, more understandable, so that we remove that the untrust that people might have regarding how the AI works. And another point I like to mention is that lack of talent needed for AI solutions to be implemented within organizations, and this has been around for a long time. We know that if we wanted to implement, we obviously need experts around that, and hiring army of data scientists for the use cases that each organization want to implement is not possible. So what we have seen that works very well in that front is, whenever that we have been able to remove or replace the manual work that needs to be done. So we know that when we are creating AI solution, we need to do lots of coding, lots of experimentation and testing. And if all those stuff that are done manually today, what we see, we replace that with or automate that, and what we see as an outcome is that organizations with a smaller team has been able to achieve a lot more. So that's one of the aspects that needs to be considered, and we're going to see that how that's important and how we can achieve that today. And again, another point is that bigger organization might be able to have the resources and budget to go and again create a bigger team and start implementing AI solutions, but that's not available for all size of the organization. Like smaller ones, they have problem accessing to the resources, talents, and again having the budget in order to go implement AI solutions. What we have seen there works very well is when the technology that is being used to create AI, if it's cheaper, if we make it easier and accessible to these organizations. And indeed, I mean, this is something that we see, as a way to make AI, adaptation easier by providing, these sort of solutions, like fostering collaboration, reducing complexity, automation, and democratization. And that's why I'm going to a little bit focus about these points. And again, this is what we see that really helps organizations to progress and reduce the risk of failure of the AI initiatives. But again, if we need more proof points, we just need to look at in the past how when we wanted to adapt new technology, what really actually what was it that we did in the past that it brought that change and adaptation of that certain technology and scaled it and made it available to a larger audience. Let's look at the printing machine. For example, when automating printing by inventing printing machine as opposed to like copying books by just handwriting, it actually democratized knowledge, and that had a great impact on enlightenment, right? And the same goes for later industrial revolution and manufacturing revolution. When, for example, during the manufacturing revolution, look at one example like cars. Indeed, inventing of cars didn't revolutionize mobility, right? It was actually when we invented assembly line, that was the moment that mobility was revolutionized. And before assembly line, cars were just hobby for rich people, not a tool for going from A to B. And assembly lines like automating producing cars made it easier to car being produced at larger scale and reduced the price and made it available to a larger consumer. And that's where actually mobility revolutionized. And there's no reason to believe that that's not going to apply to AI automation and or ML revolution. Feel. And the point that I wanted to make here is that obviously we know that using AI to automate process is going to be it's going to bring a lot of changes. But what I wanted to make the highlight here is that AI creation itself needs to be automated, or any processes in between. So let's have a look quickly here. What processes we have when we are talking about creating AI application. So the first phase of any AI application is creating artifacts like predictive models, right? And then we need to operationalize that predictive models in sort of IT environments, and then making endpoints that our application can connect to it. And the third phase, which is very important, as crucial, and when we are talking about AI adoption, and that's why we call it innovate, is applications. So these AI applications actually wrap around all these works that has been done earlier, like creating these predictive models, and then we put those predictive models in an IT environment. Now we need to wrap that around with AI application and interface it with business users. And that's the time when our investment in AI being used by our organization, because that interface or AI application allows now businesses to connect with these applications and start using it and improving their day-to-day business. And actually, there's a comment from Thomas Edison that the value of an idea lies in the using of it, right? So, and that's why I wanted to highlight that this phase has been underestimated in the last couple of years, which many organizations now realize that this is an important step in investing a lot more in that step. And that is what we actually also see when we're working with many of these organizations that are implementing AI. So let's quickly have a look on these 3 steps that we mentioned earlier. Again, when we are talking about make, we are talking about things like feature transformation and preparing data. And we have seen in the previous talk that how important is it that you have data in a raw format and accessible, and many of the data preparation and data feature transformation that are required to be done prior to be fed in algorithms. These steps could be automated actually, and that could reduce a lot of time and effort that data science teams spend to create these applications. And the other component of it is a machine learning piece, because there's no free lunch. We don't know which algorithm is going to perform best for this specific use case. Typically, we need to try out a variety of different algorithms to know that which one performs best for this specific data set, for this specific use case. So all these, creating different models, comparing them, and optimizing these models also, is part of the journey that needs to be, automated and can be automated actually. And one of the points that I mentioned earlier is that one of the barriers to implement AI is that we are not willing to change because we don't trust sometimes, and explainable AI is a great tool to increase trust by providing insights from the models that we built. So no one wants to have a black box model, even if it's accurate, when we don't know how they make predictions. We just don't have that trust to put it in production, specifically if you're talking about a regulated industry. So this explainable AI is part of the, has to be part of the journey. And any problem that we create, we need to put that in place. And again, the last piece of it is low-code app development, which is a very key issue. Again, to make that possible, whatever that we spend here being used by someone from business and delivering the value that we expect from these models to the business. And in all the things that we create here needs to be streamlined and be operated automatically in an IT environment. So we don't want to through a bunch of codes to IT now to go and deploy, but this has to be a sort of streamlined so that as soon as we get these artifacts, we create these artifacts, they are being automatically deployed and put on production. And when everything is streamlined, and what we see that emerges in organizations are internal AI app stores that now the other different users within the organization, specifically business analysts or expert from business lines, start now utilizing or using this AI application that has been created here in improving day-to-day business. Just another aspect from what I mentioned in the previous slide here. Again, I just want to highlight that how these AI applications is important. Now, if we start from data here, again, the data is a source of information, but it's not information itself. That's why we build, just analytics around data, like creating machine learning algorithms and predictive models and etc. In order to extract that information, and if you're in retail, you want to predict whether next week demand is going up or down. And if, for example, model predicts that the demand is going to rise, and we want to pass that information to someone responsible for managing resource and planning. And so we need some sort of application that transforms this or transports or displays this information to relevant people in the organization and absorbs also their action based on that information. And unless we don't have that, all this again, investment that has been spent here to create those cool algorithms and models do not, if we can make that usable by other people in the organization, again, that investment is just wasted. But you might say that, okay, these, what is the fuss around these applications? We have been developing applications for a long time. Why not just create application around that? The problem is that the classic full stack web application development, it requires front end, back end development. It's very code intensive, and it requires a big team of software engineers to be able to create that application. Which specifically when we are talking about AI use cases at the beginning, specifically when we have a certain hypothesis, but we are not sure that that really solves the problem, we typically cannot afford to have, go and all of a sudden start building a big data, software engineers together and create, a full stack, web developers for just a use case that it's an early stage. And what actually here it could help a lot is if we could make those applications, because AI application has certain characters, and a lot of piece of it could be pre-built and make it easier to be created by data scientists. And this gap has been identified with some of the organizations, like also H2O. We have worked on these, providing solutions for that piece as well. And H2O Wave SDK, is one of those applications that helps actually cover that piece, creating applications around analytics work that we are doing. This is actually open source. Feel free to give it a try if you like and see that how it solves your problems and getting your analytics works and models that you create quicker to production. So the great advantage of these sort of applications is that it doesn't require traditional web development skill sets that you need, like HTML, CSS, JavaScript. Those you don't need it. It's mainly based on Python and R code, and actually even you don't need to write lots of codes. Even if you use Python, just a couple of lines of code, and the way why it works and why it's low code, because the majority of those components that you typically need for such an application already pre-built. And you just need to say that, that's my data and that's my model that's going to predict and, present that in that form. You just need to connect these pieces and then the rest will be done. And, that actually empowers data scientists to rapidly prototype. And that helps us or data science team, to get quick feedback from the business or end user so that they make sure that the entire application are created to solve the right problem. So the quicker you get the feedback, that helps you adjust the course and you make sure that you're creating the right application for the right problem. And yeah, indeed, again, although that I mentioned that we are talking about rapid prototype, but that's production ready quality framework, which means that it has a components like single sign-on authentication, things that in enterprise still you need. And just imagine if you wanted to code just single sign-on authentication, itself requires a team to develop that component. But when you have those sort of things as part of it, component, you just need with a couple of lines coding it, and accelerate massively the amount of time that, or like reduces the time that you need to create those sort of application and deliver a solution to your business. All right, so that's more or less all I wanted to cover today. And just as a summary, again, if we want to, we saw today that what are the issues, or one of the what was the barriers to develop AI application into, or adopt those AI application in organization, and what needed to be done in order to reduce the barriers to adopt AI application. And we spoke about things like what we need to actually do like we have seen in history, is that we need to replace any manual work that possible with, and automate that piece with automation, like utilizing AutoML to creating the predictive models using MLOps, to streamline putting those models in production, and using applications like web, which with capabilities of low code development allows us to do a rapid prototyping of those business solutions. And eventually having all in one single unified platform actually reduces complexity and enables us eventually to provide things like, for every individual company and corporate, we could have internal AI app store, which allows people in that organization utilize and benefit from AI. So that's all I wanted to cover today. So that's now your turn, and go and sign up and give it a try and see that how it can accelerate actually bringing AI applications from data to productionizing and impressing your CDOs, CIOs, and CTOs. So now, guest session open for question and answer.
Thank you, Oscar. Thank you, Oscar. Great presentation. Yes, and if the audience has any questions, do type them in the Q&A chat, and we'll read them out. We actually have one question so far. The question is, from your experience, what would be the expected improvement in terms of time to production for AI projects and applications if we apply the approaches that have been discussed today, such as auto ML and low code app development?
Yeah, so that's a good question. And the thing is that, if I want to answer that question, I would approach it from two perspectives. The first is that, applying these technology actually reduces the amount of time that we deliver, these codes to business. How much it will depend a little bit on the project itself, because we know that every individual project is different and it's difficult to generalize that. But what we see typically is that if projects don't fade, and we see that 85%, 80% already fade. If they don't fade, it typically takes between 6 months to a couple of years to even first version and first prototype becomes available to be used by business. And what we have seen applying these approaches, reduces that time to as low as a couple of weeks. And I have seen personally the CDOs become excited about it, how quickly his team has been able to wrap around the solution and deliver. And and the second thing that I wanted to highlight here is that it's not just reducing the time, but when you reduce the time, you get the opportunity to quickly get feedback from business. And this is more important piece of it, because the more the quicker you can iterate, you would be able to understand better whether your solution is something that really business needs, and if not, correct the correct the course. And this gives opportunity actually to us to make sure that our solutions deliver what business needs before time, resources, and allocated budget runs out of that project. And that basically rescues project and make sure that we are delivering solutions and reducing that 80% failure rate that we've seen, hopefully.
Okay, we have another question. It is many machine learning algorithms and AI platforms' relevance to their accuracy end up with black box models, which reduces transparency and hinders AI adoption. How does H2O address these aspects?
That's a very valid question, and actually, that's interesting because indeed, AutoML or automation is an answer to that problem, because that's correct. If we are not able, one of the things that causes to be distrust in AI is the lack of transparency, right? So there are black box, and sometimes we don't understand it, we don't trust it, and if we are again in regulated industry, we wouldn't even wanted to deploy that. And in order to address that, we need to put some process in place to make sure that we understand and we get insights from these models. We get one example would be does our model have a bias in it? So we need to identify that, right? So, or when it rejects a loan, predicts that loan needs to be rejected because the default probability of that person is high. We need to be able to explain why this model makes that decision. So, and this is requirement sometimes again in regulated industry. So how we tackle that, we need just to make sure when we create that pipeline, we embed those aspects as part of the pipeline, and indeed and that's something that we understand. Indeed, in H2O, we have a dedicated team just for machine learning, interpolativity, and explainable AI, which makes sure that any pipeline, any AI pipeline that's being built in the platform and automated, it actually has those components embedded in it. So irrelevant of what type of use case we do, whatever use case that you run through that platform, because it is baked inside that pipeline. And we don't need to hire extra team for that every use case to deliver those insights, because this is automated and part of the process. It always run it. So you have always, if you have a bias detection in your pipeline, you're always going to have that component run there, and you can always look at the reports again whether your model does have a bias or not. So again, yeah, here automation is basically can help us to make sure that we always have those checks and or inside and explainability always in place, so that we can mitigate risk across all these AI initiatives that we have in our organization.
Okay, and it looks like we have one more question. So if you do have any other questions, feel free to type it in the chat or in the Q&A. What are the typical use cases that can be addressed by such a platform?
So the platform is actually, vertical agnostic. So it could be applied in any organizational type of, industry and business line, as long as we have right data available and good business question in hand. We are good to start with. But what we have from our experiences is that the typical suspect would be financial services, telecom, insurance, healthcare, and sales and marketing departments typically have use cases and retail, obviously, for things like demand forecasting, or in sales and marketing you have typical use cases like next best offer, next best action, churn, use case whether the customer is going to churn or not. And in financial services, you have things like credit risk scoring and transaction fraud, and those sort of use cases that comes in my mind now. And these are frequent use cases that we see. Or again, manufacturing, I forgot, and predictive maintenance is one of the holy grail use case that when it comes in manufacturing. So these are typical use cases that we see, because the reason that perhaps we see those use cases appear a lot is that typically these organizations have already data sets available, because when we look at financial services, insurance, telecom, they are based in they're operating based on data, so they already have a data access policy in place, and data platform in place, makes it easier to start. But again, the platform itself is industry agnostic.
Okay, perfect. Askar, thank you again for participating today. That was a fantastic presentation. Thank you to both speakers and both companies for participating today. That is a wrap for this edition of the Big Data and AI Toronto follow-up series. I would say keep on the lookout for future webinars that are going to be coming in the coming months. And we are also going to be having our next edition of the Big Data and AI Toronto event happening at the Metro Toronto Convention Centre on October 6th and 7th. So registrations will open in the spring. So stay tuned for more info on that. And again, thank you to both speakers for participating, and we'll see you in the future.
Thank you.